The two central ideas, dominance and best responses, are actually quite closely related. We'll explore that now. If you recall, we're going to represent by UD sub I the set of undominated strategies for player I. Now, for the moment, let's suppose there are only two players. I'm going to define for player I the set BI, which is all the strategies for player I that are a best response to some belief that player I could have about player J's strategy. Formally, if you have some strategy SI, and you have another strategy SI prime, and SI dominates SI prime, can SI prime be in the set BI? The answer is no. Why? Whatever belief theta j you might have, the fact that SI dominates SI prime says that UI of SI, given your belief theta j, is going to be higher than UI of SI prime theta j, because SI dominates SI prime. And this is true for all theta j. So SI prime cannot be a best response to any theta j. Thus, SI prime is not in BI. Then what we've seen here is that no dominated strategy, SI prime, can be in BI. So anything that's in BI has to be undominated. In other words, the set BI has to be a subset of the set of undominated strategies. So if we were to draw a picture, we'd have the set of all possible strategies for player I, the set of undominated strategies would be some subset of that. Not everything's undominated, some things could be dominated. So the dominated stuff would be outside. All things that are undominated would be in this set. The only things that can be a best response are some subset of this. Turns out, when you have two players, that this is actually an equality. The set of best responses is actually equal to the set of undominated strategies. I'll prove this for you in a little while. What happens when you have more than two players? I'm going to change the definition of BI just a little bit. Instead of looking at all possible beliefs that player I could have, I'm going to look at beliefs theta minus I that are in the following set. So I'm going to look specifically at beliefs where the belief of player I over the strategies of other players are from the product of the possible beliefs one could have over player 1 times the possible beliefs that you could have over player 2, and so forth. I'll explain shortly exactly why I'm doing this. So I'm going to define BI rather than being the set of strategies that are best response to any belief that player I could have over the strategies of others. I'm going to let BI just be the set of strategies in SI such that there exists some belief in specifically this set such that SI is a best response for player I to this belief theta minus I. This set BI is a set of all strategies that are best response to beliefs that are uncorrelated. So to get a better sense of what these uncorrelated beliefs are, let's take a look at an example. Let's suppose we had a game with 3 players, and we look at things from the perspective of player 1. So let's suppose in this 3-player game, player 2 has 2 possible strategies, M and N. Player 3 has 2 possible strategies, X and Y. Let's say 1 believes that player 2 will play M with probability P and N with probability 1 minus P. Similarly, player 1 believes that player 3 is going to play X with probability Q and Y with probability 1 minus Q. If these beliefs are uncorrelated, what it means is that the probability that M and X are both played would simply be P times Q. The probability that M and Y are played would be P times 1 minus Q. The probability that N and X would be played would be 1 minus P times Q. And finally, the probability that N and Y would be played would be 1 minus P times 1 minus Q. In other words, these two random variables from one's perspective, the random variable what player 2 is going to do and the random variable what player 3 is going to do, are independent. As a concrete example, if the probability with which player 2 was going to play M was a third, and the probability with which player 3 was going to play X was a quarter, then we would have these probabilities with which the various strategy profiles of players 2 and 3 would happen. Just for reference, these are referred to as the marginal probabilities. So these are the probabilities with which we could say that player 2 would play M or player 2 would play N. That's the marginal probability of player 2's strategy. When the strategies are uncorrelated, we can multiply the marginal probabilities to get the joint probabilities. So the joint probability that player 1 will play M and player 2 will play X is just the product of the marginal probability that player 2 will play M and player 3 will play X. Not all beliefs are uncorrelated, as you might imagine. Let's suppose I told you that I'm player 1 and I believe that with 1/2 probability, my opponents are going to play M and X respectively, and with the other half probability, they're going to play N and Y respectively. Are there P and Q that we could find, marginals for players 2 and 3, that would express this belief as an uncorrelated belief? The answer is no. Can we find P and Q such that when we multiply P and Q, we get a half? When we multiply P and 1 minus Q, we get 0. 1 minus P and Q, we get 0. And 1 minus P times 1 minus Q equals a half? There's no such thing. It's not possible. So this kind of belief cannot be expressed as an uncorrelated belief. So if we look at the entire set of beliefs, so all probability distributions that include correlations, that would be the set of probability distributions delta S minus I. If we look at all possible beliefs in this set, and now we look at those strategies in SI such that there exists some belief, could be correlated, could be uncorrelated, such that SI is a best response to this belief. Well, this set we're going to label BI superscript C, because here we're allowing for correlation. Important point to note here is that this is a bigger set than BI. The reason is that this set, the set of all probability distributions over S minus I, includes all of the uncorrelated probability distributions over S minus I. So if SI, little si, is a best response to an uncorrelated belief, then it has to be a best response to some belief in this set. Which means that if SI is in BI, then it has to be in BIC as well. So BI is a subset of BIC. A very important result in game theory is the following. For any finite game, what do I mean by finite game? I mean that the SIs are finite sets. So for every player, there's a finite number of strategies. So for any such finite game, BI is a subset of BIC, but that's going to be exactly equal to the set of undominated strategies for player I. So if you look at the set of all possible strategies, then as we've noted above, the set of best responses to correlated beliefs includes all the best responses to uncorrelated beliefs. That's by definition. We also saw that if something is dominated, so we look at the set of undominated strategies, and we look at something that's outside that set, can't possibly be a best response to a correlated belief. So all we need to do to show this proposition is really to prove that there's nothing in this area here. In other words, there's nothing that is undominated, but not a best response to any correlated belief. The proof is a little bit involved. In the appendix of the textbook, they go through a very simplified, hand-wavy version of the proof. I'm going to make a separate video to show you a more rigorous, thorough proof.